In connection with your dynamic spectrum access, let us see the admission control. So here the admission control decides the admission or rejection of the request for the setup and reconfiguration of radio barriers. So in your admission control decides the admission or rejection of the request for setup and reconfiguration of radio barriers. So here the admission control is partially relevant to WCDMA because there is no hard limit on maximum capacity. So here the admission control algorithm are executed separately for uplink and downlink because of different issues impacting on both communication direction. So this diagram represents a clear view of your admission control between the load and uplink interference, and the green dots are something that represent the maximum planned interference whenever a new user is blocked. So here your wireless code sense multiplex, that is WCDMA supports some multimedia services, so the admission control algorithm must take into consideration that the amount of radio resources needed for each connection request will vary. Similarly, the quality of service requirements in terms of real-time or non-real-time transmission should also be considered in an effective admission control algorithm. In addition to the connection setup request, the admission control may also be triggered by handover procedure and transport channel type switching. So here let us see how does the admission control take place. So the transmission setup request, the UMTS is always triggered from an user equipment side, and either because it is an UE itself that is initiating an interaction within the network or because of UE's answering in paging message. That is, prior to the transmission setup procedure, the signal is path from UE towards an cognitive network needs to be established, which means the case of the RAN is accomplished by means of RRC connection, that is a radio access network application part, which takes care of your radio access network and cognitive network interaction. With the help of RRC and RANAP protocol, a transaction setup request message reaches the cognitive network. So this diagram represents how does the admission control take place between radio resource access and how messages and protocols are involved in admission control. So let us see, that is, it is always a cognitive network that triggers an RAB establishment by means of RAB assignment messages sent to the from cognitive network to our SRNC. With the arrival of each message, the admission control algorithm is executed. If the connections are admitted, the SRNC establishes the resources in radio and lab interference by means of RRC radio barrier establishment procedure. Similarly, the required connections are established in LU interference. If the establishment procedure succeeds, a positive response is given in the message of RAB assignment response and RAB is eventually set up. So here something that a power control in WCDMA. So the transmitter adapts the output power according to the path class, that is mainly to solve the near far problems. Goal is that all users should experience the same SIR. Next is your open loop power control. So open loop power control is something that initially non-signaling, that is UE uses patch for access of node B if received by, then no need to for further open loop power control. So this is a power control implementation diagram, where here SAR is something that symbol to interference radio, FER is something that frame error network. So next is your closed loop power control of WCDMA. So here the inner low power control is called fast power control. This control takes place between UE and node B. Here the transmitted power in order to reach the receiver with required EB and no target. So outer loop power control, also called slow power control, it takes place between node B and RNC. So outer loop power control is responsible for selecting a suitable EB or no target depending on BLER, that is BR requirement. Congestion control. Congestion control faces a situation in which the QoS is guaranteed are at risk due to evolution of system dynamics, that is mobility aspects, increase in interference and traffic variability. So conjunction situation in radio interference are caused by excessive interference. Thus, the conjunction control algorithm need to monitor the network status continuously in order to correct the overload situation when they are present. The conjunction control algorithm needs to exhibit a fast reactivity under the overload condition in order to prevent degradation of quality of connection. So, the conjunction control and load control is closely supported by admission control and handover. So the conjunction control is closely supported by admission control and handover. And RT load, that is real time load, that is NRT is something that non-real time mode. So the conjunction control and the load control, the conjunction or load control algorithm resides in network side, will be based on measurement of acting as an algorithm inputs. When the conjunction situation is triggered and the conjunction resolution action is implemented with an aid of RRC protocol.
Excuse me,
The code management is devoted to managing the downlink code tree used to allocate a physical channel orthogonally among
Excuse me, an unknown is
different user. So the advantage of OVSF codes used in return download is perfectly orthogonal. However, the drawback of limited number of available codes. Therefore, it is important to able to allocate and reallocate the channelization of code downlink, that is called code blocking. So next one is your code management. Code blocking indicates a situation where the new cells could be accepted on the basis of interference analysis and also on the basis of spare capacity. But due to the inefficient code assignment, the spare capacity is not available for new call, that must therefore be blocked. So this is an example of call allocation preventing the code blocking. So handover of WCDMA. So in WCDMA, more possibilities are open as long as the mobile terminals can be connected to more than one cell simultaneously. So handover involves the three different steps. One is your measurement, decision and execution. So measurement may be of different categories, that is intra-frequency, interfrequency and inter-rad, that is radio access technology. Handovering decisions are taken, result is relatively comparison of on CPICH measurement. So these are the types of handover which occurs in CDMA, and these are the handovering process in CDMA. So here, one finger of track receiver is constantly scanning the neighboring of common pilot channel. When the neighboring common pilot channel receives threshold, the new RBS is added to the active setup. So this is your structure algorithm, process of soft handover. Next is your cell breathing. Cell breathing is something that depends upon the cell load level on the air interference level. This phenomenon is said to be a cell breathing. So the main conclusion is various radio resistance function which we have discussed, which helps in maintaining of quality of service for user satisfaction. The multimedia capabilities of newer technology like LTE and 4G are advanced by day. So the radio resource management will keep playing an important role in helping optimization the network. These are the reference. So if you have any clarity related to this topic, please feel free to approach me. Thank you.